Good afternoon. I welcome you to review a new set of questions. So we're going to start. This sheet specifically says this is MC 22 is the page. And again, this page only has question 41 and 42. So if you're looking at the questions and you're wondering if you got them right, the answer is C and D. So let's get to the explanations. Again, the answer is C as in Charlie, D as in dog. So let's get to it. Just circling the answer is not going to be enough notes. Let's write out how we'd work this one out. So I'm going to do question 41, and it says a math competition uses a scoring procedure that is discouraging someone from guessing. And guessing would just be to choose a number at random. So if this was a multiple choice question and there were 5 choices for each question, they give you a score of a 7 if you get it right, a 2 if it's blank, and 0 if it is incorrect. So with 5 choices for each, let's figure out what would be the minimum number of choices that a student must eliminate before it is advantageous to guess. Okay, now this is a doozy. This is a pickle of a question. So if you miss this one, no one's blaming you. This would be, I told you, every 40 questions, I get a question that I'm like, I'm not sure. But this is, what would you expect to score? So I'm going to write, this is my formula for the expected count. And I can just add all these up if I know what X is and I know the probability of getting X. And then I can just add those up. So that would be the sum. Put my little sum symbol there. Okay, so when I look at this, I say to myself, well, I gotta sketch some things out. It's kind of like this test where I have A, B, C, and D. So if I'm trying to figure out, well, what's the probability A's right, B's right, C's right, and D's right? You kind of have a 0.2 or a 20% chance of each question. So the way I got that was 1 out of 5 is 0.20. So you know that on this test, we're to assume that 1 out of the 5 is right, which means, so that's the probability of getting it right, and then the probability of getting it wrong. So 80% of the time, if I'm totally guessing, I'm going to get it totally wrong. And 20% of the time, even if I'm guessing, I'm going to get it right. So the probability of right and the probability of wrong are right here. Now I'm going to lay out, well, what if I eliminate? So let's just assume that if you eliminate, then you did eliminate a wrong answer. That would definitely change it. So let's write that out. If you eliminated one of the answer choices, so I did that there. Now there's only A, B, C, D, E, and that does totally change my probability. How I got that? Yep, so it's 1 out of 4, or 0.25 is the probability of getting it right, and 3 out of 4, 7.5 is the probability of getting it wrong. So that would look something like this. So obviously, if I definitely can eliminate a wrong answer, it definitely changes the probability. I'm going to keep going. One more time, I'm going to eliminate one more. And that would be the probability of getting one right is 1 over 3. So that's 0.3 repeating, which is the probability of getting it right. And so the probability of getting it wrong would be 2 out of 3, or 0.66 repeating, which would be the probability of getting it wrong. So I could go on like this forever, but I don't want to go on forever. I want to get done with this question. So now as I look at this, I think to myself, well, they reward me if I guess. So when I look at this, if I eliminate none, I kind of need to use my formula, and I haven't used my formula yet. So I'm going to write, if I eliminate none or 0, using my formula, 4 out of 5 would be wrong, plus 1/5 of the time it would be right. So 4 out of 5 is the probability of getting it wrong, plus 1 out of 5, that's the probability of getting it right. So that's the probability. And then what's the score of getting it right? So the score of getting it right is 7. So 1 out of 5 over 7, 4/5. Getting it wrong gives you a 0. So that's how we'd calculate that. So the x value, which is your score, the score is 7. The probability of getting it right is 1/5. And I end up getting, so I actually calculate that, and I get 7/5, which is not 2. Hold on, let me go get a easy calculator. So 7 divided by 5, I get 1.4. Well, I get 2 points for guessing. So I need to keep eliminating. Let's eliminate 1. So if I eliminate 1, then I'm going to get 3 out of 4 are wrong, but 1 out of 4 is right. So this makes sense. And then once again, I get no points for wrong, but I get 7 points for right. So I'm still using this equation. Makes sense. Then I just do my math here. I get 7 over 4. 7 divided by 4 is 1.75. So it's still not advantageous for me to guess because I get 2 points for not writing anything. Okay, let's try another one. If I eliminate 2, now I got 2 out of 3 are wrong, and 1 out of 3 is right. So I write out my formula, 2 out of 3 are wrong, and 1 out of 3 are right. So that would be 2/3, and I get 0 points for wrong, 1/3, 7 points for right. So 7 out of 3 is finally a number bigger than 2. 7 divided by 3 is 2.3 repeating. So that's why my answer is C. Next question. I really like these questions because it forces me to make a two-way table. So if I look here, it's definitely a categorical question, and they ask me 2 yes or no answers, or yes or no questions. So one question is, was it damaged during delivery? So either it is damaged during delivery or it is not damaged during, I guess I need one more delivery. Okay. And then the other part is either it will stop working in less than 2 years or it will not stop working. So that would be greater than or equal to 2 years, I guess. You could say that way. Or just not stop working in less than 2 years. Okay? And so I'm going to make a two-way table, and I know that this grand total has to be 100 if I can work in percent. So they tell me, a probability question, that the probability that the new microwave is damaged during delivery and stops working in less than 2 years is 0.04. So I rate this. Damaged during delivery and stops working in less than 2 years, 0.04. Then it says the probability it will stop working is 0.05. So that's just, it'll stop working in less than 2 years is 0.05. Okay, so I'm going to put that 0.05. So 5% of the time, 4% of the time. Again, my grand total would have to be 100% of the time once I totaled everything up in my chart. So now the other numbers is, what's the probability a new microwave is damaged during delivery? So that is 0.1. Now I could fill in a lot of information for this table using the complement, but it doesn't look like I have to because the only thing they asked is given that it is damaged during delivery. So I'm making like a little basket, and the only thing I'm putting in my basket is just this damage during delivery. So the probability, given that the microwave is damaged during delivery, what's the probability it stops working in less than 2 years? So that would be 0.4 out of 0.10. So 0.04 divided by 0.1 is 0.40. Thanks for joining.